Alright, so today we're going to be doing 3-7 notes. So go ahead and open up to 3-7 if you haven't already. 3-7 is special cases, which are 4th degree polynomials. We're also going to be throwing in some 5th degree polynomials. So we're going to be talking about how to factor these. Now the process for factoring 4th degree polynomials is surprisingly a lot more, less steps, I'd say, more simple than factoring 3rd degree. So the first type we're going to talk about is a hidden difference of squares. So what does that mean? Well, it basically means that we have a difference of squares problem, but it's not as obvious as it may always be. So how do you know when you have a hidden difference problem? How do you know when this is what you need to do? Well, you're going to recognize the format, okay? The format for these problems are either going to be where you have a coefficient in front of your x to the 4th, and then minus or plus a constant, okay? The main thing you're looking for is that you don't have like an x squared or an x. You don't have any other x's except for x to the 4th. All you have is x to the 4th and a constant, no other terms. So there's two ways this can be presented to you. You can either have it all on one side of the equation, or your constant can be on the other side of the equation as well, like this. Okay, same thing, you just have to either add or subtract it over. So when you go about solving one of these problems, you want your constant and your x to the 4th term on opposite sides of the equation. And our goal at this point is to take the square root of both sides. So we're going to take the square root of both sides. And what is the square root of 16? 4. Very good.
4x to the second?
Yes, you're right. 4x to the second. So we got to take the square root of x to the 4th. So you split it in half, the exponent. Good job. And then over here, if you take the square root of both sides, one of those sides needs to have a plus or minus. And what is the square root of 9? 3. So this is where you're at so far. And then your goal is to get the x squared by itself. So if you have a coefficient in front, you're going to divide both sides by that coefficient. And you're going to end up with x squared is equal to plus or minus 4. Well, 3 over 4. So from here, you actually have two versions of this, right? You have the x squared equal to 3/4, and you have the x squared equal to negative 3/4, right? But neither of these are fully solved yet, because technically we still haven't solved for x. So we're going to have to take the square root on each of these again, right? So you separate them because we have two versions, and we take the square root of each separately. So I'm going to take the square root of this one on the left first. I square root both sides. This leaves me with x equals plus or minus square root of 3 over 2. Because I can take the square root of 2, but I can't take the square root of 3. So this is what I end up with. And this results in, what's the two zeros that this results in? I have to write them separately. X equals
positive radical 3 over 2.
Good.
Negative, yeah.
Yes, good job. Thank you. So that results in two zeros. But we know that my polynomial is to the 4th degree, which means that I should have how many zeros? Bathroom? Yeah, go ahead. Which means I should have how many zeros? 4. Very good. I should have 4 zeros. So I still need to use this equation over here to find the other two remaining zeros. So I need to take the square root of both sides of this one over here. So I square root both sides, and I end up with x equals plus or minus. Go ahead.
I radical 3 over 2.
Good. I radical 3 over 2. Everybody understand where the I came from? When you take the square root of a negative number, you make it a positive, and you put an I on the outside, which results in the zeros. Negative I radical 3 over 2, and x equals I radical 3 over 2. So in the end, how many zeros did we end up with? 4. Sorry, I'm lagging a little bit, so it's hard to, I don't know why it's doing that. But yeah, I have.
What become the plus minus? How do you get plus minus?
Anytime you take a square root of a negative like that, that always results in a plus or minus. So if you take the square root of something on both sides, you always need to have a plus or minus, a positive and negative version of your solution. And that's because if you were to plug it back into x squared, if you square a negative number, it becomes positive. So you need those two versions. Does that answer your question?
Yeah.
Okay. So from here, we have two real solutions, and how many imaginary solutions? 2. So we have 2 and 2, which makes sense because we have a 4th degree polynomial. Now, this means that this hits the x-axis how many times?
Well, not twice.
Only twice. The other imaginary ones don't hit the x-axis. So these are our two solutions, and I want to give you guys a little hint here. Imaginary solutions always come in pairs of 2, a negative and a positive version of the pair. So keep that in mind. Do we have any questions on this one before we move on to the next? Okay, let's move on. So for the next one, I recognize the format, but I need to do something first. What do I got to do? We are going to be factoring, but we have to get...
Add the 81 to the other side.
Good. There is no GCF, but you're right. We should check for one, but there happens not to be one. But I'm going to add the 81 to the other side, which is going to leave me with 25. X to the 4th is equal to 81. So I got to get the coefficient to the other, the constant to the other side.
Square it.
Good, we're going to square root it. So from here, we're going to square root both sides. And this gives me what on my left?
Don't we divide by 25 first?
You can divide by 25 first and then square root it. You'll get the same answer in the end. So they have two options there. And then this is equal to, what's the square root of 81?
9.
Good, plus or minus 9. So you got to make sure you put the plus or minus in on one side of your equation. You pick what side. It's easier to usually do it where the x is not. And then we would divide by 5. So you, like somebody said, you can divide by the 25 first, and that's fine. You would take the square root and you'd end up with the same result. So I have x squared is equal to plus or minus 9 over 5. So that means I need to write it out as two separate equations. X squared is equal to 9 over 5, and x squared is equal to negative 9 over 5. So you got to write it out two different ways, and then you're going to solve each of these separately, okay? So how do I solve this one on the left over here? Take the square root again, which leaves me with x equals plus or minus what?
3.
Over?
Radical
3 over radical 5. Good. And that results in two zeros, the positive and the negative version of that 0. And then we got to do the same thing over here for the negative one. So I take the square root of both sides. That gives me x equals, what's the square root of negative 9? 3i. Got to put the I in, over radical 5, which leaves me with two results of zeros. X equals 3i over radical 5, and x equals negative 3i over radical 5. So how many zeros do we have, guys?
4.
4 zeros. How many real, how many imaginary?
2 each.
2 of each. And are you starting to notice a pattern of when you have to use this method? What do you notice about all the zeros? They're all fractions. That's a good point. Don't they all have the same like numerator and denominator pretty much? The only difference is 2 of them have imaginary i's, the i's for imaginary, and 2 of them are negative. So you're always going to end up with those like 4 pairs that have like the same numbers, but you're going to have 2 imaginary and then 1 negative, 1 positive. So that's when you use this method that this happens, okay? So are you guys ready to move on to the next set?
Yeah.
All right, sounds good. We're going to go to do the 420-degree trinomials. So the 420-degree trinomials, why they're called that is because we have a 4th degree, a 2nd degree, and a 0-degree term. So that's where that acronym comes from. So we're going to go ahead and factor these. Now, these factor really similarly to how you would factor a normal quadratic, okay? Yeah, that's how you'll remember it.
Oh my god.
So these factor really similarly to how you'd factor a normal quadratic. The only difference is here, instead of x, you put x squared. So then you just factor it like you're used to factoring. What are factors of 10 that add up to 7?
2 and 5.
Good. 5 and 2 are 2 and 5. Good job, guys. So the only difference here, you notice the difference is you have x squared instead of the x, because you have a 4th power instead of a 2nd power. And then we're at the stage where we can set each of these equal to what? 0. We subtract 2 on both sides. I get x squared is equal to negative 2. What's the next step in solving this one? Square root it, which gives me x equals What's the square root of negative 2? I radical 2. You can't take the square root of 2, guys.
Oh my god, I don't know why I said 1.
Everybody's thinking dividing, I think.
Yeah.
But yeah, you can't take the square root of 2, so you just leave it. But the square root of any negative just becomes I. So I just want to mention, you don't have to write out both solutions. As long as you understand this is the positive and the negative, you don't have to write them all out. I just have been making sure you understand that. But like, as we start doing like 7 zeros, I don't expect you to write all the zeros out. Obviously understand, and if it's a multiple choice, know that this represents 2 zeros, but this is a totally fine way to give me the answer to your question, okay? So moving on to the next one, what's the next thing I would do on the right?
Move the 5 over to the right side.
Good, I'm going to subtract the 5 over, and I get x squared is equal to negative 5, and then I do what?
Square root.
Square root both sides. I get x equals
I radical 5.
I radical 5, but I got to put in front of it a
Plus or minus.
plus or minus. Good, look at that. Okay, so how many zeros did I end up with?
4. 2.
4 zeros. Do you guys see all 4 zeros?
Yeah.
The positive, the negative. And they're all what? Imaginary. So does this graph ever hit the x-axis?
Nope.
No, it never hits the x-axis. So keep that in mind. Only even degree polynomials can avoid the x-axis. Odd degree ones can't because the end behavior is up, down, or down, up. So just a fun fact. Are you ready for the next one? Okay. So moving on to the next one. Now before we can even get started doing any of the new stuff we learned, we first have to factor out a GCF. And what is my GCF this time? 2. So I'm going to factor out a 2, which leaves me with 4x to the 4th plus 5x squared minus 6 is equal to 0. So everybody with me on what I just did, factored out a 2, GCF. Now from here, I can factor this like I factor any other normal quadratic. However, this quadratic has an a term that is not 1. So do you guys remember the AC method? So we're going to have to use the AC method here. So the AC method says that we can multiply our a and our c term together. You guys remember this? Kind of. So we multiply our a and our c term together, and then we factor this as we normally would. So, what are factors of negative 24 that add up to positive 5? Good, 8 and 3. And the 8 is positive, the 3 is negative. So, everybody understand why it's x squared here and not just x? Okay. And then, because we multiplied by the 4, we need to counteract that by dividing each of these. Good. So we divide each, and this becomes 2 times x squared plus 2. And this becomes, we bring it back over if it doesn't divide or reduce, 4x squared minus 3 is equal to 0, like that. And then from here, I have to set each of these equal to 0. So I just set each of the products equal to 0. What happens with the first one? Rejected. It's useless to us. And the next one? Good. Subtract 2 on both sides, which gives me x squared is equal to negative 2. And then I do what to both sides? Square root. This gives me x equals plus or minus I radical 2. There we go. So that is how many zeros on its own? 2 zeros.
Why did we divide by 4 in the second blue step?
This right here? Why did we?
Yeah.
Oh, so that's just the AC method. So the AC method basically is just where you divide by the 4 right here because we multiplied by it. So that's just the AC method. If you have to multiply your A and your C together, you have to balance it back out at the end by dividing by the A.
Okay.
Okay? Alright, moving on to the next step here. So here, I'm going to add 3 to both sides. So this becomes 4x squared is equal to 3. Everybody with me? And then I do what to solve for x squared? Good. Divide by 4. I get x squared is equal to 3 over 4, and then I do what to both sides? Square root it. This becomes x equals
Positive negative 3 over 2.
good, positive negative radical 3 over 2, like that. Before we move on from this question, does anyone have any more clarification questions on this? Any questions that you weren't sure about, any parts you weren't sure about?
Yeah.
Yes.
Why did we do the whole like with the thing with the 2 at the beginning?
Oh, why do we factor out a 2?
Yeah.
That's because that we always, anytime we factor in math, you always want to first see if you can factor out a GCF, a greatest common factor.
Oh, okay.
Okay, does that answer your question?
Yeah.
All right, anybody else? Questions? All right, sounds good. You ready to move on? All right, let's move on to the next set. So this is the hidden 420-degree trinomial. So this is like a 420-degree trinomial, but it's been multiplied by an x throughout the whole thing. So if I multiply each term by x, I can get that x out by doing what? Factoring the x out. Good. So up here, see how each term has at least one x that I can factor out. So I'm going to factor out my x first. So this becomes x times 4x to the 4th minus 8x squared plus 3 is equal to 0. So from here, we basically have a 420-degree trinomial in the parentheses. Everybody see that? So we're going to follow the same procedures and steps we've been doing on the last two after you factored out the x. So, am I able to factor this right as it is? No, we have to use what? Good, we're going to have to use AC method, right? So AC method is if you don't have a 1 here, you have to use the AC method. I think somebody on virtual asked me this. This is where you use the AC method when this value is not 1, when you have an A term like this. So we multiply right here. This becomes x to the 4th minus 8x squared plus 12. That's where I multiplied right there. Multiplied the 4 and the 3 to get 12. And then you factor it like normal. So this is going to factor into, we're looking for factors of positive 12 that add up to negative 8. Ideas? Good, negative 6 and negative 2. And since we use the AC method, which we did like a few weeks ago, so I assume you guys forget, is to divide by the A value, right? So I'm going to divide each of these by the A value. Now, if they don't divide, you usually bring the A value back in front of your x. However, you first need to reduce the fraction if possible. Can both of these fractions be reduced? Yeah, and what does the first one reduce to? Good, 3 over 2, and the next one reduces to? Negative 1/2. So you reduce the fraction first, okay? And now, technically, you could bring this back over, but we're going to just be solving for it anyway, so we don't have to bring it back over here. You can if you want, but you don't have to. So then I'm ready to just set each of these equal to 0. So x equals 0, x squared minus 3/2 is equal to 0, and x squared minus 1/2 is equal to 0. If I add 3/2 to both sides, this gives me x squared is equal to 3/2, and then I need to do what to this? Square root. Good, square root both sides. That leaves me with x equals plus or minus radical 3 over radical 2. Yeah, because I can't reduce either one.
Can you just keep it kind of how it was before, where it's just a radical over 3, like over the whole thing?
You could leave the radical over the whole thing. That's fine. Technically speaking, you're not, I don't like to say this because I'm not going to put this on. Okay. Anyways, how are we going to do the next one?
Add it to the side.
Good. Add 1/2 to both sides.
Square it.
Good. and then we take the square root, and we get x equals plus or minus 1 over radical 2. Now I should show you rationalization real quick, just in case you get a multiple choice like this. It's not hard, just takes a second. So technically speaking, they don't want you to have a radical in the denominator sometimes, so they'll do this thing called rationalization. And I'll just quickly show you what happens. So say in this case, like this one over here, this is just a side note thing. If you have 1 over radical 2, to get rid of the radical 2, you just multiply the numerator and denominator by radical 2, and you get radical 2 over 2, which is equivalent to 1 over radical 2. It's just a rationalized version of the same thing. So I don't mind if you don't like do this on your own. I just want you to know that they could write the multiple choice like this, and it's the same thing. They just multiplied the numerator and denominator by a radical. With a fraction, you can multiply the numerator and denominator by anything, and it will keep the fraction the same. So that's all they did here. So anyways, back to our regularly scheduled program here. Let's identify our zeros. So how many zeros do we have in this case? 5. Everybody see all 5 zeros? We have the 2 pairs and then the loner 0, okay? So each of these pairs, we have the negative, positive. Now, how many zeros should we have according to the degree of our polynomial? 5 zeros for the 5 degrees. So we have the right number. And how many of these zeros are imaginary?
Wait, never mind.
None of them are. Everybody see how none of the zeros are imaginary here? They're all real. They're just irrational. You can be real and irrational at the same time. You just can't be real and imaginary at the same time. You ready for the next question? Okay. So the next question, we're going to do the same procedure we've been doing. We first have to find a GCF. In this case, my GCF is what? X. So we're factoring out an x. That leaves me with x to the 4th minus 4x squared minus 5, like that. Now we can factor this into 2 binomials. Now I'm able to do this without using the AC multiplying method because my A term is what? 1. Yep, I don't have a coefficient in front of the x to the 4th. And what are factors of negative 5 that add up to negative 4? Good. Negative 5 and positive, oops, not negative 4. Negative 5 and positive 1, right? And then what do I have to do with all of these? Set them equal to 0. And then I just solve. This one's already solved. So I just add 5. I get x squared is equal to 5, and I take the square root, which gives me x equals plus or minus radical 5. And over here, I subtract 1. I get x squared is equal to negative 1, and I take the square root. What's the square root of negative 1? Plus or minus I. It's just I. Square root of 1 is negative 1 is I. You could say 1I, but you don't need to. So in the end, how many zeros do I have? These 5. See all 5? If you only see 3, make sure you let me know. We'll figure it out. So before we end the lesson, does anybody have any questions for me? No? You guys get it? How do you feel about this?
It's easy.
Easy?